We're going to jump on that one thing, decimals. All right. So we've been talking about normal distribution. I'm sorry if I interrupted you. All right. So what percent of data fills in this whole region between the green and the green? 68. So 34 on one side and 34 on the other. Agree? Okay. And then we come out a second standard deviation. So you subtract 2 standard deviations or you add 2 standard deviations. And each of these are 13.5% of the area under the curve. And then if I continue out even further, I go 3 standard deviations. Hello. If I go out even further, this one is 2.5%. And then I could subtract 3 standard deviations, and that's 2.5%. And then the last amount is 0.15%, which, friends, we can go further out. But as you go further out to the right, so beyond 3 standard deviations to the right, so 4 or 5 or 6 standard deviations to the right, or you go out to the left, -4, -5, -6 standard deviations, that, if I went out like 10 standard deviations, that falls somewhere in the 0.15% category, which is a really small percent. So if you add up the 0.15, the 2.5, the 3.5, and the 34, and then double it, because it's the same on both sides, you get to 100% of your area. So what today is going to focus on is trying to figure out, like, let's say I wanted to know how much area this was, and neither of the endpoints was the average or the standard deviation. So we're going to look at using Desmos to find us the area underneath the curve. Okay, so that's what we're basically focusing on, is area under curve. Any of you under curve, if any of you have taken any calculus or pre-calculus, the area underneath the curve is usually what you're finding based on the x-axis or the y-axis, or even the z-axis when you get to Calc 3. So the area under the curve, so each of these percents, like this region here, is 34% of the area underneath the curve. The entire area underneath the curve is 100%. So let's so we call this, standard any observations data can be rewritten as a z-score. So remember, the z-score was an observation minus the average over the standard deviation. That's how we find a z-score. The z-score is somewhere on the x-axis. The z-score is like a standard deviation that includes decimals or fractions. Also, whole numbers can work. So note about standardization. One definition of the term of standard is an idea we're using as a measure of the norm, okay, or a model of comparative evaluations. The concept of that the comparison is possible because the equal playing field has been created. It's fundamentally important to understand why z-scores have been created. After all, a z-score of +2 means 2 standard deviations above the mean, whether we're talking about the length of a song or SAT scores or the number of people who attend a musical. Okay, so the 68, 95, 99.7 rule works well on positions for normal distributions that are whole numbers, but what about the fractions? What percent of normal distribution is greater than a z-score of plus 0.75? So if you think about a 0.75, 0.75 is here, okay, where you have your mean here and 1 here. If we were to say, what percent of area is this, there are definitely ways that we can do it. Now, back in the olden days, you had to go look at the big old table of stuff and find as close as you could to 0.75 and decipher whether you're looking to the right or to the left of the area underneath the curve. We have technology that'll take care of that for us. Okay, so you can indeed use the graphing calculator for this. Okay, the TI-84s work nicely. We have the rules, but they use something called normal CDF. But what we're going to use, just double check, make sure I have my notes right. (3-4). (3-4). Oh, I thought I had it. Okay. So, all right. So let's say we were talking about wanted to find the percent of area. Now, normally the area will take place to the left. Desmos is nice because you're looking to the right or to the left, and it comes out pretty nice how it works out. And we're going to hit this. Come on up, Mr. Desmos. Come on. Okay. I know you're working. Okay, who broke my computer? It wasn't me this time. It's thinking. There we go. Okay. Nice. Monday time dorky uppy stuff. Okay, so my mouse is working. My keypad is not. There we go. All right. So Desmos. So let's go over on page 73. What if we want to know the percentage of the let's start with example 1. Now the normal CDF is what you use on your graphing calculator, but if you were to use Desmos, if you come in here and you hit your keypad and you go to functions and down to statistics, there is something I'm looking for. It's normal distribution. So we're talking about a normal distribution. If I were to say, hey, this is what a normal distribution curve looks like, you know, it's centered, this is being centered around the 0 being the mean and standard deviation being 1, 2, 3. Okay, there's a way that we could plug in if things go differently. But let's say we wanted to know what percent of the area is between a z-score of negative 0.75. So negative 0.75 is somewhere over here, okay? And then 0.25. And 0.25 would be somewhere here. So if we were to look at what percent of area falls in there, we could find it. Now, you could use calculus, but we're not there. So let's use statistics. So normal distribution, we're going to go, let's see if this is going to work. We're going to go negative 0.75. I don't think it's going to work the exact way I want it to. 0.25. Okay, that's what it is. Okay. So what you have to do on this, let me just verify. I had it written down someplace in my notes, and I don't remember where I put it because I'm a ding dong. Okay, I think what you have to do is the first thing you have to do is put what your mean would be. The mean on this case is 0. The normal standard deviation is 1. And then I'm going to do left and right bound. So I'm going to go negative 0.75, comma, and 0.25. Okay. It's not calculating it. Why? What did I do wrong? Normal distribution. And standard deviation. What am I doing wrong? Mean 0, standard deviation 1. Okay, that works. Let's see if this will work. Negative 0.75, comma, 0.25. It's changing that. There we go. That's what I want. All right. 0. So we have to plug in that and that. Now notice we have a minimum value. So we want our minimum value to be negative 0.75. And then we don't want it to go to positive infinity. We want it to go to 0.25. And if we oh, there's my mistake. You guys didn't catch that for me. There we go. There we go. So what this found us is, so we're keeping our mean of 0, and we can change that mean to anything we want. You know, if the problem says the average is 35, the standard deviation is 6, we change both of those. But then you go to find the cumulative probability. So we want our left bound to be a z-score of negative 0.75, which is to the left of the mean, and a maximum of 0.25, so it's to the right of the mean. So the area that this encompasses right here is about 37% of the area. Okay? So sorry, I kind of goofed that up for a little bit. So let's say, what if we want the percentage of normal distribution greater than a z-score of 0.75? The answer, we want to go to infinity, and the nice thing is infinity works on our problem. Okay, the calculator doesn't have an infinity button, though Desmos does. Okay, which is great. So if you're using your graphing calculator, the TI, you would plug in a really large number for a right bound, but we're going to do that. So if we wanted a value that was greater than 0.75, I'm going to change this to 0.75, and I'm going to change this. I think I can go with infinity. There we go. So let's zoom out a little bit. So that second example, if we had, again, if we're calling our average or our mean 0 and our standard deviation 1, if we wanted, what would the area under the curve to the right be? And this is where this differs on the graphing calculator sometimes. But the nice thing is, if you can't find the infinity button, you just type in the word infinity and it'll default to it. This could be negative infinity, so you put negative and then spell out infinity and it'll do it. But we're talking about 22.7% of the area underneath the curve is to the right of that. Okay? Yeah?
How did you get it to like highlighted?
Highlighted is when I plug the max and min in, and then it'll say, you know, my min, this right here is where 0.75 lives, and then infinity lives way out there forever. So it's finding the area forever that way. So again, I was talking about where our standard deviation can keep going and going. Yeah. Okay. So let's go back and do some notes. So if I wanted to find the area underneath the curve, okay, using Desmos. Okay. So what you're going to do is you're going to find the normal distribution. So find normal distribution. And then that's going to be, you know, say normal distribution. And it's going to give you parentheses. This is going to be your mean, and this will be your standard deviation. So you can change that to whatever you want. Does that make sense so far?
Yeah.
Okay. And then down below, click the box, and then it's going to give you something like this. And what this is going to originally default to, if you originally do it, is negative, positive, infinity. which in this case would be 100%. Okay, but what we're doing is we can change these to whatever the problem is given. Okay, so let's do this. Using your phones, what is the average AC, or let's do SAT score because we've done it at the national level. I need the average, and I also need the standard deviation. Please. So average AC or SAT score and standard deviation. Do we have something? $10.60 is the average. Okay. Do we have a standard deviation they gave you? So bad. How much? 300? Okay, let's go with it. I mean, I'm happy with that. Let's see, everyone else. Cat's not here. All right. So what this basically means is on a normal distribution, we'd have 1060 here. One standard deviation to the right would be 1360. 1360. And the second one would be 1660, which sometimes the standard deviation will fall out of what the maximum score could be. And then I'm subtracting 300 this way. I would subtract 600 going this way, just not worrying about the math. But let's say we want to know, let's say you found that you had a Z-score, you took the ACT, and let's just pretend they said, hey, you have a Z-score, and I know they won't, but let's just pretend. Let's say you had a Z-score of 0.73. So a 0.73, you're to the right of the average, because this is one standard deviation. So let's see how this is going to work out for us. So let's use our information. I'll write this down so I'm going to forget. $10.60, 300, and a Z-score of 0.73. So let's say we want to know a 0.73, we did better than how many people, or how much percent of people did we do better if we had a 0.73? And then the opposite end is how many people did better than me. All right, so on this, we found that 1060 was that average, and a 300 was a standard deviation. Okay, so if you hit the little plus that shows up here, this is what the normal standard deviation looks like at this point. So let's see, a 0.75. We have to work backwards. We have to work backwards to figure out where we're going to fall in. So they gave us a Z-score of 0.73. So remember, the Z-score equation is observation minus the mean over the standard deviation. So if we had a 0.73 and we want to figure out our observation minus our 1060 over our 300. You guys have a calculator available on your phone real quick? Let's do some algebra. What is 300 times 0.73? How much? 219? Thank you. And then we want to figure out our observation. So I want to add 1060 to 219. So 219 plus 1060. 14 or 1279. Okay, so the 1279's fallen in somewhere in here, right? So if I wanted to figure out what percent of people I did better than, if I do better, that means I'm going to the left, okay? So we say 12. So we're going to make this negative infinity, and my max is going to be 1279. So if I knew that my score was a 1279 on the SAT, I did better than 76.7% of the people. Now, if you wanted to reverse it, you could do one of two things. You could go 1 minus 0.767, which is pretty easy to do, or you can just flip-flop it and say, I want this one over here to be 1279, and I want to be to infinity. I want to know what percent did better than me. And that means that 0.23%, 23.3% of the population did better than I actually scored on the ACT. Okay? So it's a valuable tool, realizing the normal distribution is going to take place. If you wanted to use the actual z-score, the z-score, you would have to find, they probably wouldn't give you a z-score. They would tell you that you got a 1279. So, did you do pretty well? Well, 23.3% of the population that took the test did better than you. So you did way better than half the people that took it. So it all depends. Are you looking to the right or to the left of your information is where we're going with on this. Let's see, 1.43. So a lot of times, let me just take a look at the homework 3-4. Okay, that should work. Cool. So it looks like on the homework, we're on page 181. They're using the mean of 0 and the standard deviation of 1. Okay, so you don't have to change that. So you can just change normal distribution 0, 1, and then you're just manipulating. Think about if you're going to the right. If you want the area to the right, you're going out to infinity. If you want the area to the left, you're starting at negative infinity. But I think you all might be able to play around with this. And I wanted you to start it now so you have the opportunity to ask questions, because I know that sometimes my stuff will work pretty well. And let's do this. This will be due at the end of period tomorrow. Just because I know that you're going to have some teachers that are going to saturate you with homework because, it's your fault that we had Thanksgiving break, right? Y'all know that teacher? I had a few of them. All right, tonight, there's nothing on for you. You get to do this. Oh, thank you, teacher. All right, so I'm going to stop this here. New